All right, to start with today, we are going to review just a little bit about proportions. You might need this today, just to make sure. Just remember, when you have a proportion, you're going to cross multiply. So we have 3 times 2x equals 5 times x minus 1. You would distribute here, distribute there, set it equal to, and solve. You do the same thing on each one of these problems here. Cross multiply, and then solve for x. So when you're solving a proportion, set it up like that. We're going to be setting up proportions today in most of the assignment, but today we're talking about angle relationships and proportions of triangles. So we're going to triangles that are intersected by an angle bisector or parallel lines, and then we're going to use proportions to help us solve those. So the first one is the triangle proportionality theorem. Okay, and that's if you have a line that is parallel to one side of the triangle. So what we're talking about here is TU is parallel to QS, and if you have that, then it divides the two sides of the triangle into equal proportions. So what we're saying there is RT is going to be proportionate to TQ, and RU is going to be proportionate to US. So you'd set that up right here. You'd solve that proportion. That's if you have parallel lines. And then the converse of that is if you have parts that are proportionate, then these lines will end up being parallel. So that's just the converse of this proportion up here. Take a minute and look over each of those, and look what this one here on the bottom is saying, that if you have these proportions, then these lines are going to be parallel. This one is saying that if you have lines parallel, then these proportions will be equal. Okay, so it kind of works both ways there. We're going to set up a couple examples here, and I think that will hopefully make a little more sense. So we're looking at this right here, and they tell you right from the start that QS is parallel to UT. These red arrows also indicate that. And then they've labeled this. RS is 4, ST is 6, QU is 9. So the only thing we do not know is QR, or RQ, which we're going to call that X. So setting the proportions up, because we have these parallel lines, we would say X is to 9 as 4 is to 6. And then you just cross multiply and divide. So we have 6x is equal to 4 times 9, which is 36. So we divide by 6, and x equals 6. So x equals 6. If they wanted to know what the length of UR would be, then you would just 6 and 9 would be 15. So that'd be the length of that one. Okay? Just depending on what they're asking for. Just another example here. We have two parallel lines once again, and we call that x. They want to know what YZ is. So they want to know that length right there. So we can go 44 is to 35 as 36 is to x. Now notice that we pair these two up because they're dealing with this proportion. They're both on top, and these two are both on bottom. Okay, just keeping that in mind as far as top and bottom is concerned. And then we would cross multiply 35 times 36 equals 44 times x. So if you go ahead and solve that, 35 times 36 is 1,260, and we divide that by 44, and we get 28.6. So x equals 28.64. Depends on if they wanted it rounded to the nearest hundredths or whatever. But you should look at it and also say, yeah, that makes sense. That's a decent value for that length. Okay. So let's look at this right here. It says on the shoe rack, shown BA is 33, so this is 33. CB is 27. CD is 44. And DE is 25. And it says, explain why the shelf is not parallel to the floor. So we would set up our proportions. We would go 27 is to 33 as 44 is to 25. And if those lines are parallel, when we cross multiply, those things should equal one another. So 33 times 44 has to equal 25 times 27. You're just looking at it. These two are both smaller than these two, so there's no way that that's going to be equal, but we'll just multiply it out. 1452 and 675. So as you can tell, those two are not equal. In order for those lines to be parallel, the proportions would have to be equal. You could also go 27 divided by 33 and 44 divided by 25, and that should be equal if those lines are parallel. Okay? So that's just one way that you could check that and make sure and see if those lines are parallel. All right, now, they want you to determine whether these lines are parallel. So we want to know if these two lines right here and right here are parallel, and if they are, then these two proportions should be the same. So we can go 90 over 50 as 72 is to 40. And when we cross multiply, these two things should be equal to one another if the lines are parallel. I know that 9 times 4 is 36, so that's going to be 3,600. And then I need to multiply 50 times 72, and I believe that's also 3,600. And it is. So because those things are equal, I know that these two lines are parallel. So this would be the math that you'd have to provide in order to prove that those lines are parallel. Okay? The second theorem is three parallel lines. So we have three parallel lines, and if they're intersected by two transversals, so this L and M would be transversals. Okay? And if they are intersected, they're saying that UW is to WY as VX is to ZX. So you're setting up proportions once again. Notice that these two right here are on the same transversal. So they're saying this length is proportionate to that length as that length is proportionate to this length here. And that's what they're setting up, and then you can cross multiply and divide and solve to figure out lengths and so forth. So we're going to do a couple examples here. So looking at this, they've labeled all these. They said this one's 120, 150, and 300. And they want to know the total length of that right there. But in order to do that, we're going to have to find that length first, and then we can add them together. Because they want to know, let's see, find the distance of HF, which would be for distance from Main Street to South Main Street. So we would set this up as we would go x is to 120 as 300 is to 150. Now you could have went 120 over x and 150 over 300. Get the same answer either way. We cross multiply and we get 150x equals 36,000. So we divide 36,000 by 150. Then we get x equals 240 when we divide by 150. So this right here is 240. So they want to know the total length. So we add those two together, 120 plus 240, and we get 360. So HF is going to be equal to 360. All right. Let's try, I think we have one more of those. Oh, we're moving on to the other theorem here. We have the angle bisector theorem. Okay? This is setting up a proportion here once again. When a triangle is bisected, or the angle is bisected here, so we're talking about this ray right here cuts this angle in half. When it does that, it means that AD is proportionate to DB. And then it also means that AC is proportionate to BC. Okay? So So it sets up that proportion, and then you're able to solve the triangle here. So in the triangle, QPR is congruent to QPS, or in this. So here's our angles that are bisected. So we know proportionately, this one is proportionate to this one right here. And we know those are set up. So we can go 7 is to 13 as, now when we're trying to figure this side length here, this can be a little bit confusing. We know that this is x and we know that's 15. So it's hard to say what that length is going to be because we don't know what x is. But we do know that if we take 15 and subtract x, it's going to give us that length. So that length is actually 15 minus x, and this length is x. So that's how you would set up that proportion and solve it. So when I solve that, I have 7 times x is 7x, and I have 13 times 15 minus x. And 13 times 15 is 195. So this is 195 minus 13x equals 7x. We add 13x over, and we get 20x is equal to 195. We divide by 20, and 195 divided by 20 is 9.75. So x equals 9.75. Okay. So this distance down here is 9.75. So we go 15 minus that. And we get 5.25. So this distance up here is 5.25. So that's the distance of QR. They wanted you to find RS. So we did find that. It is 9.75 for solving for x. All right. Here's one more similar to that. Find the length of the given segment. So they want you to find BD. So they want you to find x right here. So to set this up, you'd go 16 over 40 equals x over 30. And then you would cross multiply 40x equals 16 times 30 and solve that one. This one right here, they want you to find JM, so we go 16 over x equals 15 over 18. You would cross multiply, and we get 15x is equal to 16 times 18 and solve that. When you solve those just for practice, you should get, let's see, for number 3 you should get 12, and number 4 you should get 19.2 when you solve those. Just look these over. Your homework should be really similar to this. Look these over. We will be assigning the homework. It wouldn't hurt you to watch these videos twice. They're not very long. It wouldn't hurt you to watch them twice if you're struggling with this. Please reach out to us if you have questions. And this is the last section for this chapter. So be prepared for a review coming up and a test coming up the first part of next week. We'll probably review on Monday and test on Tuesday or Wednesday. We'll let you know. We'll be in touch. Thank you. Have a good day. How long was that one?
Kurt, I don't know where it went. I just told it to save, but
It's probably click on the box up above.
this,
Nope.